Hello and welcome to this video on alkanes as fuels, and we're going to in this video study the combustion of these alkanes, so combustion. So we're going to have a look at both complete and incomplete combustion, the reactions that take place there. After that we're going to have a look at the pollution, and that would be the pollution from burning these fuels. And we're going to distinguish between the pollution that we get out of vehicles and the pollution that we get from power stations. And then after that, the third and last topics would be global warming. Global warming, which of course comes from carbon dioxide amongst other greenhouse gases, which is one of the products of the combustion of alkanes. Okay, so that's what we're going to do today. Let's start with combustion. So combustion, let's start off by looking at complete combustion. And here we have a Bunsen burner with the air hole open. And because the air hole is open, that means we get plenty of oxygen. Okay, so this represents complete combustion. And you see how the flame's nice blue color. Complete combustion, and that occurs when there is plenty of oxygen. And when we have complete combustion, the combustion equation looks like this. Let's take propane, for example. Propane, the formula of propane is C3H8. And when we've got plenty of oxygen, we'd have at least 5 moles of oxygen gas for every mole of propane. And then we're going to make carbon dioxide for complete combustion and water vapor, like that. But to make them balanced, we need 3 carbon dioxides and 4 water molecules. So that is an example of a complete combustion reaction. So the important things to notice are plenty of oxygen and the products being carbon dioxide and water. So now we can move on to incomplete combustion, and this is a picture of a Bunsen burner with the air hole closed. So we've got less oxygen being able to get into the Bunsen burner and therefore mix with the methane. So we've got too little oxygen, insufficient oxygen. So let's label this one incomplete combustion, and then insufficient oxygen, in which case we don't get carbon dioxide created. We can get particulates, which is just sort of sooty particles of carbon, and carbon monoxide. So let's have a look at the balanced equation for incomplete combustion of propane again. So propane, we've got C3H8, and if we have too little oxygen, let's say at this time we've only got 3.5 moles of oxygen to go with 1 mole of propane, in which case we're going to make 3 moles of carbon monoxide this time, and still some water vapor. Okay, so that's an example of the incomplete combustion equation, and the important thing to notice is that we've got too little oxygen for complete combustion, so we get carbon monoxide instead of carbon dioxide. And that's a problem because that causes, carbon monoxide is poisonous. It causes breathing difficulties because the carbon monoxide binds to the hemoglobin in the red blood cells, and it binds to the same sites in the hemoglobin that oxygen wants to bind to, and so it stops oxygen getting into your cells. What's more, you also get, so let's just write this in green, so as well as carbon monoxide, we're going to get carbon particles, which are sometimes called soot, which are carcinogenic, And you'll notice those when you've got a safety flame or a yellow flame, and if you put that under your gauze on top of your tripod in class, then you'll see the gauze going all black, and that would be because the carbon is depositing on the gauze, and that's why we make it a roaring flame before we put it under the gauze. So that's it for combustion for this lesson. What we shall have a look at now is pollution. We'll start off with pollution from the combustion that goes on in vehicles. Okay, so like we said, we're going to have a look at pollution from burning fuels in vehicles. So let's have a look at this diagram first. And this is a series of contraptions that are attached to the engine of a car. So let's just write engine here. Right, so the gases that come out of the engine come into the catalytic converter, make their way through the particulate filter. Muffler just reduces the noise before they come out of the exhaust pipe. And in the engine, of course, we've got petrol or diesel usually, and that's burning with oxygen to make various products. Now, as you know, air also contains nitrogen, and at the temperatures of a combustion engine, and the pressures as well, high pressure in a combustion engine as well as high temperature, the nitrogen that's in the air does react with the oxygen. Obviously it doesn't when it's just at room temperature. Nitrogen stays nitrogen and oxygen stays oxygen at room temperature. But in a combustion engine, the nitrogen in the air can react with the oxygen, and that's unfortunate because it makes nitrogen oxides, which are toxic and poisonous. And so here's some of the reactions that happen. So you've got nitrogen from the air, and you've got oxygen from the air, and an unwanted reaction in a car engine would be to create two molecules of nitrogen monoxide. And so nitrogen monoxide is poisonous, we don't want that. And what's more, the nitrogen monoxide would also react with more oxygen from the air, go on to a further reaction to make nitrogen dioxide, like so. So all these nitrogen monoxide, nitrogen dioxide, both toxic and poisonous, and so we need to get rid of them before they get out of the exhaust of the car, and that is the function of the catalytic converter, one of the functions. But first, also what we get out of the engine is carbon monoxide. So let's represent that in red here, carbon monoxide. We want carbon dioxide, at least in preference to carbon monoxide, because carbon monoxide is poisonous. So we've got some carbon monoxide coming out of the exhaust. And also, let's use a different color for unburnt hydrocarbons. Not all the petrol molecules or diesel molecules are burnt completely. So some of them, let's represent them as smaller hydrocarbons. Let's say C3H8. Let's say we've got some unburnt hydrocarbons coming out here as well. So there are three types of pollutant that come straight out of the engine, and they're all nasty, so we want to do something to them before they get out of the exhaust and into our breathing air. So that's where the catalytic converter comes in. So in more detail, here's the catalytic converter, and what we can see is that these nitrogen oxides are represented on the right hand side here by NOx, and we've got in red, here's our carbon monoxide, and that you see I'm just circling in red on the entry to the catalytic converter. So we're just taking this catalytic converter here and illustrating it in more detail here, and the HC here stands for so this HC that I'm circling now, that stands for our unburnt hydrocarbons, which I've circled on the left there as C3H8. So as you can see, let's stick with the unburnt hydrocarbons. They're going to turn into carbon dioxide and water, so they're going to be just completely combusted in the catalytic converter. So let's do that reaction there. We're going to start with our, so let's draw a little line here. So in our catalytic converter, we're going to start with our C3H8. We're going to just completely combust that. That didn't happen. It should have happened really in the piston of the engine, but if it didn't, then we have to do it in the catalytic converter. So we're going to add some more oxygen to it and just turn it into carbon dioxide and water vapor. And you can see the carbon dioxide and water vapor on the right hand side there coming out of the catalytic converter. So next, let's go back to the nitrogen oxides. So let's draw a little line from NOx. So we've got reactions that go on in the catalytic converter that basically do the reverse of the reaction that happened in the engine. So we're going to take nitrogen monoxide, for example. Let's say we've got some nitrogen monoxide coming into the catalytic converter, and we're just going to split that back into, let's have two of those molecules. So we can have a nitrogen molecule and an oxygen molecule. So both of which are harmless to humans. And while we're at it, we'll deal with our carbon monoxide. So let's switch to red because this is our carbon monoxide. So our carbon monoxide is going to react with some of our nitrogen oxide, and we're going to make nitrogen. So we're going to make some nitrogen and some carbon dioxide, like so, which you can see nitrogen there and carbon dioxide there again. And so, in summary, we can see that coming out of the engine, we've got mainly three nasty things: unburnt hydrocarbons, like this one here. We've got carbon monoxide, like this one here, and we've got nitrogen monoxide. So they're the three nasty things that come out of an engine, and catalytic converters will convert them into less nasty things, i.e. carbon dioxide, nitrogen and water molecules, so that we're less poisoned. And that's what you need to know about pollution from burning fuels in vehicles. Some fuels, less so these days because fuels have been cleaned up quite a bit, but some fuels do have sulfur in them, in which case you might get some sulfur dioxide, but we're going to deal with that sort of pollution on the next slide. Yes, and the next slide is dealing with pollution from burning fuels in power station, and we should be clear here that we're talking about fossil fuels. We're talking about fossil fuels like coal and gas. Coal and gas, and in this country we don't really have oil-fired power stations, but that would be the same. We're not talking about power stations that use renewable energy or create renewable energy from renewable fuels. So let's first have a look at such a power station. This is actually the Drax power station, I think the biggest power station in the country, in North Yorkshire. And let's just highlight a few of the components of this power station. Let's use red because then you'll see, I think, this big pile of coal. All right, so that's coal. So we're burning coal in this power station. Actually, these big fat towers, they're just cooling towers. Cooling towers. So that white stuff there is just water vapor coming out there. That's not the nasty stuff. This chimney here is where the carbon dioxide is coming out of. So the carbon dioxide and more water vapor is coming out of the top of that chimney there because all the combustion is happening in this unit here. So that's the basics of a coal-fired power station. But the problem with coal-fired power stations and other fossil fuels is that as well as carbon dioxide, we've also got sulfur impurities. We've got sulfur impurities, and when those sulfur impurities get burnt, we make sulfur dioxide, and sulfur dioxide dissolves in the clouds and eventually makes sulfuric acid, like that. Let's just call it acid, which becomes acid rain. So lots of acid rain is from the sulfur impurities in the fossil fuels of power stations. A small proportion of it comes from cars as well. And some of acid rain is actually nitric acid from the nitrogen oxides that come out the back end of cars as well. But this is the major component of acid rain, sulfuric acid from sulfur impurities in coal and gas. Mainly coal, less gas. And that acid rain, as we know, is harmful to lots of things, including forests and of course lakes. It would acidify lakes. And so not nice. So what we have to do to avoid all of the acid rain that would destroy our forests, farms, lakes, etc., is that we would use alkaline slurries in our chimneys. So going back to the left-hand picture, let's also have another look at this chimney. So in this chimney, we can take calcium oxide, and that comes from limestone, and you can also use calcium hydroxide as well. But most of it is calcium oxide, and you're going to mix that with water to make a slurry, and then you're going to let the exhaust from the burning of the fossil fuels go through this slurry, right? So in the exhaust is your sulfur dioxide that you want to remove, because you don't want it to go into the clouds and create acid rain, and instead it in the chimney reacts with the calcium oxide slurry and makes calcium sulfate, which is harmless. And so that's how we avoid acid rain, by extracting the sulfur dioxide from the flue gas of the power station. So that just leaves us to study global warming, because burning anything, whether it be the fuels in a vehicle or the fuels in a power station, or indeed some renewable fuels like wood chips, burning anything makes carbon dioxide, and that carbon dioxide finds its way into the atmosphere, and then we've got global warming from the greenhouse effect. So here we've got a diagram that will help us explain the basics of the greenhouse effect. But in this lesson we don't need the details of the greenhouse effect, just the basics. So you can see on this diagram here, let's pick out some interesting bits. This molecule here could possibly represent a carbon dioxide molecule. This is probably trying to represent a water molecule. This looks like a methane molecule. Don't know what that looks like, but it's probably a CFC. But in any case, we've got the three main greenhouse gases, being carbon dioxide, methane, and water vapor. And the one thing I would just want to highlight about them is that the sun heats up the Earth, all right? And so the Earth has got its own heat, not only from the sun's energy, but also from its own radioactive energy from the core, and it ends up emitting its own infrared radiation and other frequencies of radiation, and that infrared radiation we represent by this squiggly line here some of it is going to find its way into the bonds of a carbon dioxide molecule. And it just so happens that the bond energy of a carbon-oxygen double bond in a carbon dioxide molecule is just the right energy for the infrared that's coming off the planet. Okay, so that those bonds in carbon dioxide molecules, and in fact water and methane molecules as well, happens to absorb the infrared radiation that's coming off the planet that would otherwise go out to space. So if a carbon dioxide molecule wasn't there in the atmosphere, this infrared radiation would just leave and go off into space. But the more carbon dioxide molecules you have, the more that it's going to be absorbed. And so those carbon dioxide molecules in the atmosphere have absorbed some of the Earth's radiation and heated up themselves. And so that radiation gets sent back to the planet because that's what hot objects do. Okay, so that's the basics of global warming, and fossil fuels are going to make carbon dioxide when you burn them, and that's what you need to know. Hope that's been clear.